Good evening. Today we're going to talk about the parent functions of y equals sine x and y equals cosine x. At this point in pre-cal, we start our study of trigonometry. And we're going to start by visiting the graphs of trig functions. And we're going to start off with these two graphs, being able to graph the sine function, cosine function for the next we can have, and then we'll move into tangent, cotangent, cosecant, and secant. Okay, this is what we're going to talk about today is a review of graphing that we did in Algebra 2 with trig. Y equals sine x, y equals cosine x. If you remember, these functions are known as periodic functions. And they're a periodic function because, I want to give you a moment to think, why do you think they're periodic functions? I hope you're thinking the word cycle. It's because periodic functions cycle. They have patterns they continue to follow. Alright, so some key vocabulary here. These are both periodic functions because they're cycles. Period. The distance it takes to complete one cycle. Okay? If you're asked to find the period of one of these functions, it's the distance it takes to complete one cycle. Now, amplitude. I'm going to give you the long, fancy definition and then basically tell you what it really means. Amplitude equals half the difference between the maximum and minimum values of the function. Mr. Esther, what all does that basically boil down to? Basically, guys, it's just the height of the graph. How high or how low does it go down? So I'm going to put down here height of the graph. Okay, you take the absolute value of the height of the graph. Alright, so what we're going to talk about now is first talk about how do we arrive at these parent functions. And then after we do these two problems, I'm going to really tell you what I want you to know about both of these parent functions. Alright, so if you turn to the left on page 1, we want to graph the parent function y equals sine x. Alright, this is where, while we've been reviewing unit circle trig, all your Triggy Tuesday to this point right here. We're going to fill in, these are x values, these are the y values. So I'm going to plug each one of these in for x. Sine of 0. So let me show you, what is that talking about? Okay, let's think of this. Zeros right here. What's your ordered pair? 1, 0. 0, 1. Negative 1, 0. 0, negative 1. I want this, sorry, let that focus in. Sorry. I want the sine as this. That means you want the y value. Pi of 6, you should know. I'm going to write these order pairs over so you can see. Alright, pi over 6 is quadrant 1. Let's talk. So here's quadrant 1. So pi over 6, you want the sine, that's 1/2. Square root of 2 over 2. Square root of 3 over 2. Pi over 2, that's here. That would be 1. 2 pi over 3 is in quadrant 2. In quadrant 2, your y's are positive, so that's going to be square root of 3 over 2, square root of 2 over 2, 1/2. Pi is right here. The sine of pi is 0. Now we move into quadrant 3 to this point. Quadrant 3. Well, you know in quadrant 3 your y is negative. 7 pi over 6 will be negative 1/2. Negative square root of 2. 4 pi over 3 will be negative square root of 3 over 2. 3 pi over 2 is here. That would be negative 1. Then we move into quadrant 4. Y is negative. Negative square root of 3 over 2. Negative square root of 2 over 2. 11 pi over 6 will be negative 1/2. I'm going to go ahead and add 2 pi here. Back here would be 0. So that is what we're going to graph in just a second. You said, Mr. Esther, I don't know how to graph square root of 2 over 2 and square root of 3 over 2. I want you to get your calculator up there and get a decimal approximation. Alright, so let's get a decimal approximation. Square root of 2 divided by 2, that's about 0.7. Then square root of 3 divided by 2, 0.9. Okay. Alright, so let's see the highest that we go up to our y value is 1. And then the lowest we go down to is negative 1. That deals with our amplitude. Now, I'm going to write all these on my x-axis. I'll just stand mine out a little bit. Okay, now plot the points. We start here 0, 0. And continue plotting these points. And you get the parent function graph of y equals sine x. Okay, you might be thinking, okay, Ms. Chester, what do we have to do on the test? I do expect you to be able to graph the parent function and identify some key characteristics, but I don't expect you to have to do all these points because that is a lot. But you see how the general shape is. Let's notice something. It starts at the origin, goes up to 1, comes back to pi at 0, right here. So let's notice some things, okay? So let's write some notes on y equals sine x. Based on our picture, what is the amplitude of this function? The amplitude, how high does it go? Goes up to 1, go down to -1. Take the absolute value of 1 is 1, absolute value of -1 is 1. So the amplitude is 1. So we need to know that the amplitude is 1. If I ask you the amplitude of sine x, you should tell me 1. Now let's talk about the period. What's the distance it takes to complete one cycle? That's the period. We start here, because it keeps going and going. It keeps going and going. So what's the distance from here to here is completing one cycle? From 0 to 2 pi, it's a 2 pi distance. So your period is 2 pi. You need to know the period of the sine function is 2 pi. Alright? Domain. This thing keeps going and going and going and going. It's periodic. It keeps cycling. So and it even goes before. It keeps going and going and going and going. So it is all real numbers. The range how high and how low does it go from -1 to 1? So it's be -1 to 1. I'm going to ask you something. Since this function keeps going and going and going, do you think it has end behavior? Remember, when we have polynomials, we have something that has end behavior. You know, that's what we'll talk about. But does this have end behavior since it keeps going and going? It does not. It does not, because it's oscillating. Oscillation means it's going up and down, like music waves, like a heartbeat. It's oscillations. So it's not end behavior. Alright, now, you need to be able to sketch the parent function of sine. And when I mean sketch, amplitude is 1. I just want you, instead of having to list all of these, I just want you to do the major points. And what I mean by major points is the 0, the 90, the 180, the 270, okay? But I want you to do in terms of radians, pi over 2, pi, 3 pi over 2, and 2 pi, okay? So I'm going to do pi over 2, pi, 3 pi over 2, and 2 pi. So I just want you to hit the major points. So if I start at 0, what's my sine of 0? 0. At pi over 2, it is 1. Pi at 0. -1, 1. And that is my parent function. That's what you need to be able to do, is just be able to graph the parent sine function at the 4 main points around the graph. So going back to review, y equals sine x, amplitude is 1. Amplitude is 1, period is 2 pi. Here's your domain range. We need to be able to graph y equals sine x using the major points. 0, pi over 2, pi, 3 pi over 2, 2 pi. That's how I came at this graph. Remember, starts at the origin, ends back at 2 pi. The period is 2 pi. Okay, let's look at the next one. Y equals cosine x. I hope everybody's got this down for sine. Let's go fill in this. Okay, if I plug 0 here, that gives me 1. Pi over 6 is square root of 3 over 2, square root of 2 over 2, 1/2, 0. Okay, cosine is your x value, so I'm going to quadrant 2, your x is negative. Negative 1/2, negative square root of 2 over 2, negative square root of 3 over 2, pi is at negative 1. Remember, quadrant 3, your x is negative. Negative square root of 3 over 2, negative square root of 2 over 2, negative 1/2. 3 pi over 2, it is 0. 5 pi over 3, remember, in fourth quadrant, your x is positive. going out to 2 pi. If you notice, the highest value and the lowest value goes up to 1. So the amplitude for cosine is 1 as well. Okay? I'm going to put all my x coordinates on this. Okay. Start at 0, go up to 1. Notice the difference right here between sine and cosine. Sine starts at the origin. Cosine starts at the amplitude. Graph it. And there's your cosine. Okay, so notice that the sine goes like this, starts at the origin, ends back at 0. Okay, cosine starts at the amplitude of 1, goes down to -1, comes back up to the amplitude of 1. So let's talk about some characteristics of the cosine. So y equals cosine x. Once again, the amplitude is 1. If I ask you that, you need to be able to tell me that quick. Period. How long does it take, the distance it takes to complete one cycle? Because remember, cosine keeps going too. It's periodic. Okay, so it takes a period of 2 pi as well. So the period for both the sine and the cosine is 2 pi. Your domain, all real numbers, and your range is -1 to 1. It oscillates from -1 to 1. Okay? I'm letting it focus in, okay? So you do need to know these characteristics for your assessment and need to know these by Monday. Alright, so I'm going to sketch the parent function. And once again, do the major 4 points around the unit. Alright, so I'm going to have pi over 2, pi, 3 pi over 2, and 2 pi. Alright, so cosine at 0, that is 1. Cosine at pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. Cosine of 2 pi is 1. And that is my graph for the cosine. So there's two distinct shapes. Sine starts at 0 and is back on the x-axis. Cosine starts at the amplitude and finishes at the amplitude. So you do need to know the graphs and these characteristics. Alright, let's look at this middle part here. It says these are the basic shapes of sine and cosine. The period of both the graphs is 2 pi. Remember, period is the distance it takes to complete one cycle. The period is the length of one cycle. Okay. Now, let's talk about how you can determine period and amplitude for graphs is other than the parent. It says for y equals a sine bx. Okay, it's saying whatever number's sitting here, you take the absolute value, and that's the amplitude of the function. That is the amplitude of the function. For example, you look at this one. The number understood from cosine is 1. Absolute value is 1. That's the amplitude. Here, take the absolute value of this number. Amplitude, absolute value 3 is 3. That would be the amplitude. Now, okay, you said, Ms. Scherzer, can we use that on the parents? Yes, because look back here. Why is it sine x? What's the number in front of that? 1. So the absolute value 1 is 1. That's how you knew the amplitude for this function was going to 1, negative 1. Same thing for cosine. Cosine, the value of 1 is, the number seen here is 1. Take the absolute value is 1. Now, to find the period of a sine and cosine, you take, say, 2 pi divided by whatever number is sitting here. Okay, 2 pi divided by that, and that gives you the period and length of one cycle. You see, Mr. Scherzer, okay, what does that mean? Okay, you see there's a 2 sitting here. If I was to find the period of this, I would say 2 pi divided by 2, which is equal to pi. This would be pi, and then my amplitude is 1, because it's the absolute value of this. The amplitude of this is 3. To find the period, my formula is 2 pi divided by b, 2 pi divided by 4, which reduces 2 pi over 2. And that will be my period. And from that, on Monday, we're going to learn and take this and be able to graph these functions. So please understand this material, understand these characteristics, be able to sketch these, and tell me the characteristics. And I will see you on Monday. Thank you.